Hi, I'm Stacey and I'm with Maria and she's going to show us the microelectricity kit. Maria, can you tell us what the microelectricity kit is?
Yeah, as you can see here, I have all the components displayed. They are arranged in groups. In the first group here, we have all the devices that we can connect in our electricity kits. And as you can see, they are ordinary devices that we can find in any electricity circuit. Here we have various items that we can use for magnetism and electromagnetism experiments, all of them, from ion filings to bar magnets to Magna-Dürr magnets and so on. Here we have the items that we use for the connections, and these perhaps are unique to the kit, especially the springs and the strips that we are going to talk later on. And here we have the batteries that we supply our circuits.
So Maria, how do we take all these individual components and actually connect them?
Yeah, as you can see, there are not many connecting wires here because they are not really necessary. But what we need is those springs. The springs can fit exactly in these little wells in the micro well plate. And then when you bend the spring, once the spring is inside the well, it's easy to bend it with your finger. And once it's bent, you can insert here the various terminals from components. For example, here we have a bulb, it's already in its bulb holder. You bend the spring and you see how easy it is to slide in the bulb. We can also slide the other a strip of metallic strip, for example, maybe we need it at some circuit. Similarly, we can connect any of these other components. Let me show you something with it. To connect a component, it's better, for most of these components, the best connection is to put two springs so that you leave two holes apart to make it easier for your fingers to manipulate the component. For example, here we have the bulb. We bend the one spring first and then the second, and the bulb is well connected. This is a very good connection. If we want to connect next to the bulb something else in series, again we insert a spring, two holes apart again. Say now we want to connect a resistor. Here is a resistor. The resistor, you can bend its lead, there is no problem. So you can insert it, you bend the spring, insert the one lead, bend the other spring, insert the other lead. So we have now those two devices connected in series. Similarly, say that we want to connect an LED. The LED, because it's not a good advice to bend the leads of the LED. However, how do I connect it? I put two springs next to one another and I stand the LED upright, and the connection is quite good. I'm going to connect my three bulbs in parallel in this direction. The best thing is to start with the springs. Connect again springs at remember, two holes in between all of them. In where I'm going to connect the bulbs. So you see here, here, and here I'm going to connect the three bulbs to be in parallel. Now I need a connection along those springs. So for this, the best and the easier option is to use two copper strips. And after I have put the springs in place, I just connect all the springs together with a copper, like that. Okay? And the same thing on the other side. And so this is the hardest part, to insert the copper strips, okay? It doesn't matter if they stick out. Now I can connect my bulbs the normal way that we did before. So we can connect one there. The second one. And the third one. And of course, here or on the other side, I can connect my battery again. And remember, in these circuits, if you want to place a switch as well, you just add an extra spring and you connect your two paper clips there. But For the time being, there is no need for the switch. And we have our 3 bulbs in parallel. If you want to disconnect one of the bulbs to see what happens to the others, there's no need to remove the bulb completely. You just unscrew one bulb and it is as good as being out of the circuit to see the brightness of the other bulbs.
Is there any way to measure the circuit?
To take measurements? Yes, of course. And for that reason, we usually use the multimeter because it can be used as an ammeter or a voltmeter or even an ohm meter. So it's 3 in 1. But I'll show you how to measure. But before that, let me show you how to connect the 2 leads of the multimeter. The black lead must go to the hole in this multimeter, to the bottom hole, which shows the sign of the earth, ground. The red one, the red lead, in most of the cases, has to be inserted in the socket which is labeled volts, ohms, and milliamperes. In this case, it is the middle socket. So these 2 sockets are the ones that we are going to use in all of our measurements, except in one case. And this exception is if you use this range for current that is marked 10 ampere. Only if you use this range, it is the only time where this red lead has to go to the top socket, which is marked 10 ampere DC. This is the only time. Unfortunately, you must not forget to do this change, because if you forget, all your readings will be wrong. So in this case, let's leave it in the middle socket, which is the most common socket. Now, let's say that we want to measure the potential difference across the bulbs, across the connection. Say we want to connect our voltmeter in this position across the 2 springs. Okay, this will be a voltmeter now. This is the ranges for the voltmeter. We're going to use the range marked 20, which means it measures up to 20 volts, because our batteries are 3 volts, so this is the best range. Anything above would be too large, anything below would be too little. So I need to connect my 2 probes to the 2 springs. I need to tell you that if you connect them like that, this is not a good connection, because it's not stable and your reading fluctuates. The best way to connect them is to bend the springs again and connect the probes in the spring to make a good sturdy connection. Like that. You see now, it shows minus 1,91 here. This is volts, minus 9,1 volt. The minus is because I have connected my red and the black opposite to the way the battery is connected. You see the red is here and the black is here, and I have connected them in the other way around. The good thing is when we use a multimeter, it doesn't matter if you make the mistake to connect the cable, the probes the other way around. You just see a minus, means that the red should be there and the black should be there. But the meter is not in any danger. The reading will be still the same, just the minus. If we want to measure total current, we need to break our circuit here to insert our ammeter somewhere in this position or to the other side of the battery. So we need another spring. All right. Let's connect our battery now. So we made an opening. So here at the opening is where we are going to connect our ammeter to measure the total current. So remember, the probes must be inserted in the springs if you need to have a good reading, stable reading. Now, this is an ammeter now. The ammeter range is all these 4 ranges that we see here, from 200 microampere to 200 milliampere. usually the range that we are going to use will be the 200 milliamperes. If this is too small, we can use the next one. Let's see. Yeah, you see this one here. It shows 1 on the left. Mm-hmm. This means it's a message that the meter tells me that I am out of range. In other words, the current here is larger than 200 milliampere, which means I have to go up one range. And the next range to go is the 10 ampere. Okay. But now that I'm using this range, 10 ampere, I have to remember to remove this red lead from the middle hole and insert it to the hole, the correct hole, which is marked with 10 ampere. And I get a reading now that says 0,50, 0,49. This is amperes now. 0,49 ampere.